Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the significance of the equilibrium constant. So let's get into this. So in my previous video we talked about the equilibrium constant and where that comes from. So let's kind of recap that. So here we have our generic equation where I have reactants A and B with their coefficients A and B, small letters. And then I have that's forming a couple of products, C and D, and they have their coefficients, little c and d. And again, the way you figure out the equilibrium constant is you have to remember that it is a ratio, and you have the products on the top, reactants on the bottom. And so it's going to be the concentration of product C raised to its coefficient C, and you have the product multiplied by the product D, the concentration of D raised to its coefficient, little d. And then the same thing on the bottom with the reactants. So the reactants are multiplied together, the concentrations of those reactants are multiplied together, and both of them are raised to their respective coefficients. And so we have a ratio here. So you ought to keep in mind that the equilibrium constant is a ratio between products and reactants. So you have products in the numerator, reactants in the denominator. So what does that mean with regard to the equation itself? When we have a balanced equation, when we have a reaction at equilibrium, what is this constant telling us? So if we keep in mind that we have a ratio here, then what happens when you have more products? So again, remember, this is at equilibrium. So this constant tells us something about the reaction at equilibrium. It doesn't tell us anything about before or after, just at equilibrium. So if you have a reaction at equilibrium and you have a certain value of your constant, that means something. So if you have more products, right? If your numerator is bigger than your denominator, right, you're going to have a large value here, a large K value. So, but if you have a large denominator compared to your numerator, so small numerator, large denominator, then that's going to end up in a smaller value for K. So what does this mean then? If you produce at equilibrium, if you have more product, if your numerator is larger than your reactants in the denominator, that's going to end up being a larger value. So, and if you look here, that means that the forward reaction is favored, right? So the forward reaction is favored, meaning that it's going to produce more products. So remember, the point of equilibrium can lie either far on the product side, meaning that a lot of products are formed, and so you have very little reactant left. So that means that for this equilibrium, for this reaction, the equilibrium is favoring the forward reaction. So at equilibrium, when you finally reach equilibrium for your reaction, then that means that you're going to have a lot of product formed and you're going to have a little bit of reactant left over. It's still going to be there, but it's going to be a small amount compared to the product. So when you think of it that way, then that means that this numerator is going to be large compared to the denominator, which is going to be small. And when that happens, you get a K value that's large. And so what that means is that the forward reaction is favored. So it's going to favor the product side. So the equilibrium point is going to lie far to the right. So when we think about right and left, we're thinking about reactants and products. So right, where do the products lie? On the reaction, the products lie on the right side of the equation. The reactants lie on the left. So when we say that the equilibrium point, it lies far to the right, it means it's lying far on the product side. So it favors making products. It favors the forward reaction. So that's what I have here. So reactants at that point at equilibrium means you have much more products compared to reactants at equilibrium. So, okay. So, but what if it's the other way? So, what if you have at equilibrium, when the reaction reaches equilibrium, your reactants are larger. You have more reactants, so your denominator is going to be large, respectively, compared to your products. So, when that happens, your K value is going to be small. And what does that mean? It means that the reverse reaction is favored. That means that the reaction going this way is going to be favored at equilibrium, meaning that you're going to have a lot of reactants left and not so much product at equilibrium. So that means that the top part is going to be small. The numerator is going to be relatively small compared to the denominator, which is your reactants. And so when that happens, you're going to get a small K value that's going to be much, much less than 1. And then again, that means that the reverse reaction is favored. So the reverse reaction wants to be going that way. So that's going to be more favored than the forward reaction. So reactants are going to be wanting to be made more than the products being made. So when that happens, you're going to end up with more reactants on this side, more reactants here, less product here. And so that makes the K value small, very small. And so we say that the equilibrium point lies far to the left. The reactants are on the left. So favors the reactants. It favors the reverse reaction. So reactants are going to be larger. Your amount of reactants are going to be larger than your products at equilibrium. So all of this is applying at equilibrium. What if your K value, your equilibrium constant, is approximately 1? What if it's close to 1? Then that means that neither side is favored. The forward reaction nor the reverse reaction is favored in this case. So they're kind of balanced in the middle. They're meeting in the middle. So that would mean that this numerator and the denominator would be close to being equal to each other. Okay, so here's a couple of examples I have. So you have this reaction here, this reversible reaction where you have hydrogen gas reacting with bromine gas to form oops, I made a mistake there. That should be HBr, 2HBr. And so in this reaction, they calculate the equilibrium constant to be 1.9 times 10 to the 19th at this temperature, 25 degrees Celsius. So remember in the previous video that your equilibrium constant is dependent upon temperature. So this is only true at this temperature, 25 degrees Celsius. If it was at 30 degrees Celsius, this number would not be the same. It would be a different constant, right? So keep that in mind. So at 25 degrees Celsius, the equilibrium constant for this reaction is 1.9 times 10 to the 19. Notice that this is a very large number. So this K value is huge, meaning what? It's much, much greater than 1. So this means that the numerator is much, much bigger than the denominator. So what does that tell us? That tells us that we have much more product at equilibrium than reactant. So if we have more product than reactant at equilibrium, that means that the forward reaction is favored, right? So that means that the equilibrium point lies far to the right, okay, favoring the products on the right side of the equation. What about this reaction here? We have N2 gas reacting with oxygen gas, and then that's going to form 2NO gas, nitrogen monoxide. So here we have the equilibrium constant at 25 degrees Celsius. So let me fix that. So this, you can see, is 4.1 times 10 to the negative 31. Negative 31, that's a very, very small number. And that's telling us that the denominator in this case is much, much larger than the numerator, thus making the K value very, very small. So since this bottom part is the reactance, the reactants are being favored. You have much more reactants than products at equilibrium. And so that means that the equilibrium point falls far to the left. So that means that the reverse reaction is favored. It wants to go this way more than this way. And so again, in this case, reactants are much, much greater than the products at equilibrium. So that's the significance. That's what this equilibrium constant tells us for various reactions. I hope this is helpful. I hope you learned something. If you did, please like that button, hit that like button. Make sure you hit that notification bell, subscribe to my channel, that notification bell. If you hit it, you'll be notified by other videos I put out. Put a comment in the comment section. Let me know what you think. Let me know if you have any questions. Thanks for joining me. Have a great day.